Hello everyone, this is Ravit, and in this video I'll be showing what you need to do for this first part of AITS DNNC. So in this first part of the project, we'll have to create unit test cases for onnx operators. Hope you all had a chance to check out the onnx documentation. And so here I just have a list of supported onnx operators. What we need to do is to create an onnx graph for a simple onnx graph for each of these operators. For instance, in the absolute value, we'll have a single input as x, the output as y, and y is equal to absolute value of x. So it's a very simple graph that we're creating out of each operator. And for each operator, we'll create .onx file. And the second part is that we have a parser. Now the parser is used to convert .onx to .sim files. So .sim files are the custom symbol table format that we referenced in the documentation. And so we'll be creating these two things, the .onx file, and from there we'll be creating the .sim file. And the purpose is that by creating these test cases, we'll be able to test future versions of the parser. And so that's the motivation. And so first thing we need to do is to clone this repository DNN compiler. I have Ubuntu here, but it should work fairly in a similar manner for other operating systems. So git clone. Okay, now the first thing I want to show is the parser. So it's in cd python onnxparser.py. So this is the file. Um, Now this is the parser file. There's a lot of code here, but the main takeaway is this parse method. Now this parse method over here is the main method that is responsible for converting a .onx file to a .sim file, and this is the one we're going to be using. And so this is actually used in the testing, and we've automated the process to make it easier for you all to get started. So now we're going to go to slash test slash parser, and here we're going to go to create test cases. And in this create test cases, there's this file execute.py, and this simply has stores the operators and their corresponding information to create the .onx graph. And so for this sigmoid operation, which is one of the supported uh, operators, I just did a sample one, sigmoid. Uh, we have the inputs specified as a placeholder float, as well as the output specified, and that's pretty much it. We just run it and it'll create the .onx file as well as the .sim output. So let's test that out. Um, Python execute.py. All right, so it has created in test. We can see here test cases sigmoid. Now it has created .onx, .text, and sigmoid generator.py. .onx is the binary onnx file containing the onnx graph that we created using just the sigmoid operator. This text is a protobuf version of the same graph, just more readable. And this py file is the Python file that is used to generate the outputs. So the other output, as I mentioned, was the .sim output. So, and that is in the gold files folder. So if you click on sigmoid.sim, we see that this is the symbol table representation in the syntax in the documentation. So let's do another example right here for into the first operator, absolute value. So to get started on that, we need to edit the um, execute.py file, and so we just have to create a new element of the dictionary called abs, and that's just another Python dictionary. And there are three uh, features specified. One is the nodes, uh, the other is inputs, and the other one is outputs. So these are three things we have to specify. Nodes includes the the operation. So in this case, we're working with absolute value. So we'll say helper dot make node abs. The second argument here is a list of inputs. Here we can call the input anything we want. In this case, let's say x. And the third argument is a list of the outputs. In this case, there's also only one output for the apps operator. So we can say quotation y. Okay, that's nodes. And this is actually a list in case there's more than one node in the graph. Second input is contains the inputs for the graph for the operation. So in this case, we can have a simple tensor. I'll just copy the basic format in this sigmoid here. So helper dot make tensor value info, and in this case, our input is called x. So I'll keep that here. Let's keep the format as float, tensor photo dot float, and the dimension, let's say, is 2 3. Um, Great. Oops. Now outputs. So the outputs would is uh, another string. You need to be careful with this quotations. There we go. So it's again a list containing a string of the outputs. So I'll again make a placeholder helper dot make insert value info. This output as specified here is called y. I'm going to call that y. I can't use that. It's what do I do here? Let's replace the outer ones with single quotes. Um, and the format, data format is also float. And the dimension is same 2 3. So these are the three attributes that you need to specify, and that's it. You just write the file and you can execute this. Okay, it looks like there's an error. Forgot the closing parentheses, so let's go back. Maybe forgot it here. Let's try that again. And so it's rewriting the sigmoid as well. But as you can see here, it's added the second gold file, the symbol table for oops, absolute value, which is relatively straightforward. And we also have the .onnx file, the .text file in the readable format, as well as the file used to generate that. And just an additional comment for the reason why there are strings here in this dictionary is that um, we're using these strings to make a new Python file, and that Python file is executed. and these little strings that you see here are used to make the generator files. So that's the reason. And so that's pretty much it. We have to complete operators like these for the about 150 operators listed on this onnx file. So that's the task. Thanks.